Let us learn the sampling theorem. So when we sample any signal, so this is the simplest way to understand sampling. We see that there is a mechanical switch and this is the input signal, which is a modulating signal. So what is sampling? So basically this mechanical switch will start rotating. So whenever this switch will close, I will get the instantaneous value of the signal, and that is my sampled output. So this switch is rotating, so whenever this switch closes, we get the instantaneous value of the modulating signal, and that is nothing but that is the sampled signal of modulating signal. So let's start. So if I start it, so this is how this switch is rotating. The switch closes, I am getting the sample here, then again switch closes, I am getting sample here, then again closes, then again. So this switch is rotating and we are getting the samples. Now we can see that as of now I am getting only 4 samples of this modulating signal, 1, 2, 3 and 4. So then what is sampling frequency? If I increase the sampling frequency, that means I am increasing the rotating speed of this mechanical switch. When the switch will start rotating fastly, so obviously we will be getting more number of samples from the modulating signal. So I am increasing the rotating speed, which is nothing but which is the sampling frequency. So you can see that now switch is rotating fast and it is getting close and we are getting more number of samples. So this is how the sampling of modulating signal is being takes place, and this is a mechanical switch analogy. Then there is another term into sampling which everybody should understand, and that is basically a sample pulse duty cycle. So what is sample pulse duty cycle? The sample pulse duty cycle in context of this mechanical switch is that for how much time this switch is closed. You can see that switch gets closed and again it gets instantly open. So we have to see that for how much time this switch is closed. If switch is closed for more number of time, so definitely the sample what I am getting the instantaneous value, that samples width will also be more, and if that width is more, so the area under the curve will be more, and that means the power content into that sample is more. So if I increase the switch time, so that is the close time, that is the sample pulse duty cycle, you can see that now I started getting thick samples based on the sample pulse duty cycle, because switch is closed for more time, and that is the reason the sample pulse duty cycle is basically playing a role. So if I increase further, you can see that now the samples are having much more width, so definitely the area under the curve is more, so power content of the sample is more. Now this is having a very important role into the sampling and reconstruction.